Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, the emergence of the global data network with co-founder and CEO of MacroMeta, Chetan Venkatesh. Chetan, welcome to the show.
Thank you very much, Darren. It's a pleasure to be here. I appreciate the opportunity.
So, Chetan, you are the CEO and co-founder of MacroMeta. Mm-hmm. Why did you do this?
Well, some people think I'm just a sucker for punishment because this is my fourth startup, Darren. And, I like to, truly, I've been solving the same problem for 20 years now. But, it's what I call the spiral staircase, right? You're sort of going up. So you sort of see the same things, but you see them from different elevations. And that gives you a different perspective. So just my background, I'm an engineer turned, operations and startup guy, primarily because I was not a great engineer. I was an okay engineer, and there were people who were way better than me. And when I started to work with customers, I realized, hey, this is something I can do, which is take all this complex technical stuff and translate it into the world of the customer in a way that makes sense to them, because they don't care about all these technical things. They just want to solve a problem. Luckily for me, there's a place in the world. So I was able to sort of take those complex technical ideas and turn that into business value. And I've been working in databases and data infrastructure for 22 years, 3 startups prior to this, most of them dealing with distributed data and trying to reduce latency. So I've been trying to help the world shave milliseconds for 20 years now. So I might have given you, a few seconds back in your life, Darren.
Well, there you go. Thank you.
What did you do with those seconds? I want to know what you did with those seconds.
I completely wasted them downloading cat videos on YouTube. That's what I did.
Well, my mission is accomplished.
Great. Well, I'm glad that you're up-leveling because you and I are very similar this way. I'm an okay engineer, software engineer, but where my superpower is like yours, right? I can take really complex ideas and make them easier for people to understand. So let's see how good both of us do today, making the complex world of data management, especially now that data is no longer in your data center.
Right.
It's in the cloud. It's on the edge. It's on people's laptops. It's on mobile device. It's everywhere now. Mm-hmm. And how do you effectively manage all of that? That's going to be tough.
Yeah, we live, I think, in sort of the wild west of data now. Mark Andreessen said something like software is eating the world or something like that about 10, 12 years back. And I think software has sort of eaten everything at this point and largely turned, all kinds of constraints and barriers into opportunities. And one of the barriers that's come down with cloud now is just multi-region computing. You can basically build applications that run in different parts of the world at the same time. How crazy is that?
That's pretty crazy when you think about it, yeah.
And more importantly, I think what's exciting is that there is this developer movement that's happening in parallel to make everything simple as it needs to be for you to be able to use them. The average person, with some computer science background can build these types of things. So it's really interesting because we've got on one side this very sophisticated technology evolution, and the other side a simplicity movement coming from developers, to make everything simple and easy to use. And you're seeing fabulous, amazing constructs like Jamstack, for example, that allow this sort of distributed computing to happen at scale with a great deal of simplicity. Super exciting stuff, but there's still so much of open space and vast frontier yet to be discovered and claimed. And I think that's sort of the big land rush opportunity at the edge. Distributed data management and edge are just two sides of the same coin. They're almost synonyms in many ways. And
what I found on this is really interesting because you talked about the software developers and that whole community that's been built around serverless, function as a service, like Jamstacks and things like that. They all ignore data. There's this perception that data is ubiquitously available everywhere. And what I have learned by working a lot on the edge is I have a lot of edge now that isn't connected all the time. I can't guarantee that my application has access to all the data all the time. So this is a big problem.
It is a huge problem, and a part of it is that we've been spoiled by centralized computing. Think about it. Like, all the computer science you and I learned was centralized, right? Hey, bring all your data and turn it into one giant pile in one place, and then you can slice and dice it with consistency, with all these different guarantees that are called ACID, all that fun stuff, right? And so we got spoiled. And so one of the things that came out of the cloud movement, which is a pattern in the cloud, but is an anti-pattern when it comes to data management, especially distributed data, is this notion of stateless microservices. Stateless works great for decoupling data and compute. But to your point, when data is distributed and you need to bring compute to where data is, not shipping data to where compute is, that statelessness ends up becoming a huge barrier. And so you actually need to embrace a more stateful way of doing things. And so you're right. You're absolutely right. People have not figured out how to do stateful things. And that's why Jamstack and all these serverless functions and all that stuff treat data as sort of a second-class citizen, as sort of a peripheral issue, not a core issue. When it's
which I think is hilarious, right? When you think about it, why do we even write code?
Yeah, to do something with data.
To do something with data. Well, I guess if you're a gamer, no, you're still doing something with data, but
you're always state.
You always are. And so this concept, I'm stateless, I don't care. I don't know where it came from, except for, I guess, a very focused and myopic view of the present. But the future that we have today, it falls apart.
Well, and if I can take a minute to talk about state versus statelessness, because it's a really interesting issue. We don't appreciate, and I'll give a little bit of a historical picture here. We don't appreciate statelessness as really a consequence of very good Unix design philosophy. Like POSIX basically cleaned up state and said state has to be these discrete things, and it goes in specific places at specific times. And it created this very clean separation between compute and state, and allowed statelessness to come as a first order consequence of that, right? Versus statefulness, state complicates everything. It makes everything expensive. And messy, yeah. And it forces people to start thinking in data structures that are not easy to reason with, and that's the hardest problem about state. When you're stateless, your data structures are super simple, right? And you have very specific places at which you commit your data, and then you move on and you're stateless again, right? So you kind of build up a little bit of state, and then you write it, and then you move on. So at any point you lose something, it's that little bit of intermediary state that you've built up, right? Versus in stateful, you need infrastructures that are far more powerful, that are data structurally more complex, because they're supporting the application as it continually emits state. And we're moving into a real-time streaming data world, and that's continually emitting state from somewhere. And so the infrastructures are just not designed for that. And that's where my company, MacroMeta, comes in, because we've really built a new platform for this sort of continuous real-time active state that is happening at zetta, beta, gajillion byte scale.
Gajillion bytes, yeah.
Yeah, exactly.
This is interesting because I've recently been doing a lot of research in OT infrastructure and the difference between OT and IT. OT has state. All OT devices have state, right? And I think this is fascinating that you brought up that, the IT world, we kind of separated the two. Maybe that might be why there's so much contention between the OT and IT professionals and industries as a whole. Because on the IT side, we've kind of ignored state. But I like how you said, now we've got streaming data that has active dynamic state. I mean, that's a major shift for a lot of IT software developers.
Yeah, if you, again, I'll take an evolutionary perspective here and say almost everything we've done with data is historical in nature. We're great at looking at the rearview mirror and saying, I passed that thing already, or I passed this last quarter, last season. But we're terrible at looking at the windscreen and seeing what's coming our way. Our systems don't support that, which is counterintuitive. You'd think that, just given a human, neural bias, right, towards predicting the future, we would have been overly invested in technologies that allow you to process data in real time. But no, we've actually built a great competence in processing data that's historical. And that's actually what's really, in my opinion, the shift that's happening this decade. A lot of what we did since the first cloud infrastructures came, and then the big data platforms came, and then data as a service started to emerge, was just get very efficient at ingesting and processing and analyzing historical data. But now we're starting to get into a world where data needs to be, you need to think of data as on a spectrum rather than as these, just one monolithic thing. Because data has maybe 5 or 6 qualities that are now starting to get appreciated. The first one is data has perishable insight value. Data has shelf life, right?
When you first brought this up, I thought this was hilarious because the first thing that came to my mind is bananas. Mm-hmm. Right? Because bananas, I lived in Brazil for 2 years, and I know what real ripe bananas are. We don't have those in the U.S. unless they're like totally brown. Mm. But to have a very ripe banana, you watch it go through its progress, and then it spoils. So you're saying the same sort of thing with data. It has really important value, but as time goes on, that value can spoil over time, right?
Bingo. There's shelf life in data, and I think, again, there's different types of shelf life. There's data that is valid in tens of milliseconds, to hundreds of milliseconds. There's some value there, and then it's sort of the half-life of that data just sort of falls off the cliff. There's not enough value to do things with it. Then there's other forms of data that are sort of really hundreds of milliseconds to seconds and so on and so forth. The big data systems really operate at the level of, many seconds, multiple seconds and onwards to minutes. But substantially, almost everything we want to do, which comes with trying to interact between systems or people and systems, those timescales are too big. Our brain's too fast for those timescales. So we need systems that are really within 50 milliseconds for us to build, to be able to communicate efficiently and reduce cognitive overhead for those people who are interacting with those systems. Latency is actually, latency is a big cognitive overload for most people. I mean, imagine watching a choppy video on YouTube. You hate it, right? I mean,
I change channels.
You change channels, right? I mean, the minute your Netflix starts to buffer on your screen, you're like, what's going on? And, you're off. So latency, most people misunderstand. It's not something that gives you joy. The lack of latency makes you very upset and angry. It's just a cognitive function of our brains, right? Now, that's human latency, right? Our perceptions of latency are like 75 milliseconds and below, or 50 milliseconds and below. 50 milliseconds for a machine is an eternity. It can do a gazillion things in those 50 milliseconds. So latency ends up becoming sort of this very key thing. And so when you start to look through, data has shelf life and perishable value, you just start to see problems in a little bit of a different perspective. The second issue is, and now because of cloud and, interconnectivity and global systems, and startups are global companies now. It's not like the old days where you had to be an IBM, to be in 20 countries, right? I mean, my tiny little startup, 120 people, 12 countries, right? We operate in all these different regimes. And so everyone's global, and their data is location sensitive now. Some of that data is probably regulated. You've got some PII you're connecting, and guess what? If you're in certain jurisdictions, that data can't be exfiltrated. You shouldn't be sending it out of the country. This whole privacy shield, thing that happened between the U.S. and Europe is a great example of that. The Europeans really don't want their data leaving their borders. And unfortunately, guess what? All the cloud infrastructure is mostly here, and we build our applications here. It's not because we want everyone's data; it's just because this is where we built the data centers and the clouds, right?
Right.
So there's some interesting problems with data sensitivity and location, and I think the third part of this is also that data sits in all these kinds of places. There are boundaries between systems. Physical boundaries. They're in different data centers. They're in different parts of the world. They're geographically distributed. Or there are logical boundaries, which is I've got an app that needs data that's in this part of the business and another part of data that's in a supply chain with a partner, for example. So data essentially is very static and rigid, and what we need is infrastructures that allow you to connect data, get it flowing in real time with consistency guarantees, with ordering guarantees, but most importantly, be able to turn that data into fungibility, create fungibility with the data, allow it to be consumed very rapidly and quickly in diverse ways through putting APIs on that data. So that's sort of the second thing that's driving a lot of this movement away, right, towards distributed. which is the location and the boundaries. And the third thing is a lot of data just has a lot of noise in it. There's very little signal, lots of noise, and it makes no sense to backhaul all of that data intercontinental distances, paying transfer fees to our network providers, only to throw most of it away, when we get it over there because we're filtering or aggregating or doing things like that. So when you start to appreciate, these aspects of data gravity, that data originates in certain places and loses value by the time it gets to its destination, that there's location boundaries and sensitivity to those things. There's also high refresh rate and changes in data, right? I mean, a lot of systems are daisy chained to process data. I'll take data from this system, process it, and push it on to the next thing, right? And what ends up happening is, you start to see data that is very high refresh rate, and so systems are working on stale versions of data. They're not seeing the latest version of the data. They've computed on something that's stale. It's kind of like the whole starlight problem. When we look into the sky, we're seeing light from stars that came 1 billion years back, right? 1 million years back.
Yeah.
Well, guess what? In terms of latency, your system is seeing data that could, metaphorically speaking, is 1 million years old. It's useless. It's because it's stale. And so we need new infrastructures. We need new ways of solving these type of distributed data problems. And I think the next 10 years belongs to this area in data sciences.
So do you think this is? Am I just going to fix this with infrastructure changes, or is this going to cause a paradigm shift in programming models as well? Or can I leverage what I've just spent the last 20 years doing, right? Can I leverage that stuff in this new world where data is king, or not?
Yeah.
Do you see where I'm going with that?
No, I think it has to be incremental. Otherwise, it's not going to get broad scale adoption. I mean, we are an incremental species and civilization, right? Disruptive changes, as much as they're disruptive, still have some sort of an on ramp and on board that you can get on with, right? And I think we saw that with the first generation of distributed data solutions. A lot of folks tried to build distributed data solutions using some exotic technologies. Maybe 10 years back, there was technologies called operational transformation, and Google Docs is a great example of that. And everybody thought operational transformation is how we're going to solve this data problem, for distributed data. But operational transformation requires centralization of the control layer, and so it doesn't scale very well because the more participants you have that are trying to distribute data and coordinate consistency and ordering of data, that centralized layer becomes the choke point. Now, in Google's case, they've got extensive infrastructure, very smart scientists, so they've figured out a way to make operational transformation work at scale with things like Google Docs. But that doesn't generalize very well to the average developer, right? In fact, if you think about distributed data problems, there are maybe only 5 companies in the world that really understand it at vast scales. That's Amazon, Google, Facebook, Azure, and Google, right? Those are the 5 companies.
Yeah.
And so most of the body of knowledge about how to solve distributed data at scale is locked up in those companies in proprietary tech and NDAs. And what we're doing at MacroMeta, at least, is sort of working with community as well as with academia to try and create just a new body of knowledge, far more efficient than some of these centralized models, to be able to do this in a fully distributed way.
This reminds me a lot of the problem that was prevalent in the late 90s and early 2000s with high performance computing. Similar type of problem when they started building the first clouds, which they call grids. Yeah. With disparate systems scattered all over the place, they had the same sort of problem. I have data that needs to be scattered all over the place, but I need it with low latency. I need it as close to the compute as it is. Do we have any learnings from that old grid storage space?
Oh, absolutely. I mean, Hadoop is the consequence of that, right?
Yeah, that's true.
Yeah, I think great things came out of the HPC clustering grid stuff. I mean, you've given me memories over here. I'm remembering Linux and the Beowulf project from back in the early 2000s.
That's right.
It was so exciting because suddenly you could put things together. There was another amazing. I'm sorry, I'm going to reminisce for a second. But one of my
No, that's fine.
one of my favorite projects from that time was a project called Mozix, Open Mozix from.
I remember.
I think it might have been a university in Israel that did that. I believe it was a Moshe something or the other who built that. Amazing piece of tech, and I built my first 3D rendering farm using that technology. People are building rendering farms today. I built a rendering farm as a service, 15 years back using OpenMosix, because you could upload a ray tracing file and we would farm it out using OpenMosix to 25 servers.
That's hilarious. Yeah. I wrote my senior thesis on distributed ray tracing.
Oh wow!
Yeah, so are we the same person?
I know.
We might be the same person.
It feels like
hilarious.
It feels like we're versions of each other here.
Yeah, we are. This is pretty funny.
Yeah.
All right. So let's dig into a little bit on what MacroMeta has tackled and how, as a developer, or maybe not even as a developer, right? As a systems engineer, as a solutions engineer, how would I leverage something like what you guys provide? Is it just this, hey, data is available everywhere, or what exactly did MacroMeta tackle for us?
Yeah, so we think that there's already a lot of high quality, infrastructure available for solving sort of this historical system of record type of problems. I mean, we've got databases that are amazing, right? And today, you can go into the cloud and you can fire up a planet scale or an RDS and you can throw infinite amounts of historical data at it and it'll chomp it up like a champion, right? And, same thing with data lakes. You've got snowflakes, you've got the Databricks of the world, all that. They're great at historical stuff. And they're trying to move towards real time, but their architectures fundamentally aren't meant for these things. They're rare view systems, as I like to call them. But these new problems with data where there's time sensitivity, location sensitivity, actuation value, refresh rates, data gravity, data noise, they require a new infrastructure. And I think of these as systems of interaction because they're closer to where data originates, they're closer to where data is consumed, they're closer to where people are. And so you can't solve systems of interaction problems with systems of record because systems of record are databases and data warehouses. Systems of interactions are data networks because here, you need to ingest data, you need to filter, enrich, augment all of that inline, and you need to route data to its intended recipient systems or people. It's a network. It's a networking function. Now suddenly you need to start data like packets, and you need network processors that are moving data around. And that's what MacroMeta has built, which is a global data network. And it's a serverless API system. It's a serverless platform that developers simply consume our APIs. And we now give them these abilities through those APIs to solve these, real-time active data, operational data problems that they have. And, just to double-click one layer deep into the global data network that MacroMeta operates, think of it as sort of something like Akamai, a CDN, right? A topology like a CDN, but a data platform like Snowflake. Imagine you smash those two together. In one of those linear accelerators, right? Like the one in CERN. And, you got this exotic new infrastructure that came out from smashing these two, prototypes. That's what MacroMeta is. It's a global data network in the topology of a CDN like Akamai or Cloudflare or Fastly. But on the other end, it's actually a data platform like Snowflake and MongoDB that gives you very rich data primitives to be able to deal with these real-time active data, operational data, values.
So I can take my analytics that I want to do on real time and the tools that I'm used to using, and I can integrate them in with this global data network so that I can deploy these analytics anywhere, close to where the data is generated or where the data is required, where the data comes in, correct? Is that
exactly? So exactly. Instead of, I'll give you a couple of direct examples. In the retail world, for example, we're all used to getting next day delivery or same day delivery in many cases, and that's the Amazon.
Yeah, nowadays we are.
We are, right, and that's the Amazon Prime effect. But remember, 5 years, 6 years back when we didn't have it, it used to take 2 weeks to get to us. But we're not going back to that world anymore because Amazon fundamentally changed retail distribution with an edge architecture. Instead of fulfilling everything from a single fulfillment center in a state or in a region, they built caches of physical goods close to you and me. so that when we order, they can basically locate which is the closest place and ship it from there to us, right? And then clever algorithms keep telling them what are the most popular things to keep in different caches, basically. So what MacroMeta has done is fundamentally build the Amazon Prime for data, which is we're basically bringing data and computation on that data much closer to where you are and allowing that to happen in milliseconds. So we can allow you, for example, to put our network in front of your apps. And, in retail, as an example, a lot of retail customers use us as a way to connect the in-store inventory with their fulfillment system and the e-commerce system. So as an example, you're shopping for hardware. You're doing a new home project. You go to your favorite, version of Home Depot or whatever that is. As you're shopping and you add things to your basket, those are items that are actually in the closest store to you. So you never get oversubscribed. Because that's one of the biggest frustrations, for example, people who are doing these types of things have, which is I bought 5 parts from here, they ran out, I got to go to the next store. Where's the visibility for all of this? So this ability to create real-time loops of data in retail is extraordinarily powerful because it allows the small guys who don't have Amazon's computer science and cloud and all of that to really be able to compete with Amazon. So, we're seeing a lot of that sort of intersection of retail and edge and real-time data as a powerful enabler. Another one is in cybersecurity. Some of our customers are cybersecurity enterprises that are ripping out their centralized data models and creating distributed data models to take advantage of lower latency so they can block threats in real time.
Yeah, so that's a really good use case because the sheer volume of data that's generated from network logs or system logs, host logs is huge. And today I was talking to a agency in the U.S. government. They bring all their cyber threat logs back to the U.S. to do all their processing, and then they'll tell you 2 days later if you've been that you can't do that. So with your guys' stuff, I can push that analytics out to the edge very easily, right? Do I have to? Do you guys have like orchestration where I can say, hey, go run this on all these types of data, and it will distribute my containers or analytics? It'll distribute those out, or do I have to do that distribution myself?
No, you don't have to do the distribution yourself. You connect us to your data sources and your data destinations, and we sit in the middle and take care of all of this in real time for you.
So you take care of all the orchestration of
data
of dropping my server, my stateless serverless container close to where the data is,
exactly.
so it can do its job.
If I can share 3 slides, it might actually be helpful. Is that something I could do?
Absolutely.
Yeah. Okay. Great.
Absolutely.
So as I was explaining, the global data network really addresses sort of this real-time needs around data and data management and analytics, right? And it sort of acts as plumbing. It's a little transformation layer that you put between your data sources and receivers, with the consumers and the publishers, and it sort of takes care of it. It's composed of 3 technology pieces. The first is what we call the global data mesh. It's the integration layer for data. The second is the global compute fabric that allows you to orchestrate data and business logic in the form of functions and containers globally. And then the third piece is what we call the global privacy fabric, which is the way to secure data and comply with different data regimes and regulations that might be in effect wherever your data is, either transiting or being stored. So let's start with the global data mesh, which really is a way for you to integrate data from different systems just very quickly and easily. So you've got systems that are sitting in across different boundaries, maybe physical boundaries of data center and region. Maybe there are geo-distributed data. Some is in Europe, some is over here. Maybe it's logical. You've got data in one part of your business and systems in one part of your business, and maybe other data in partner systems, for example. And so the data mesh acts as a way for you to integrate all of this stuff and get data flowing with consistency and with ordering guarantees, which is one of the biggest and hardest problems over here, because data can get really it can get all kind of twisted ways, right, when you start getting it flowing. But the biggest value of this global data mesh is that it makes data fungible and consumable by allowing you to put APIs on data very, very quickly. So, you might spend months trying to, clean, curate data and then put an API on it. Over here, we use the global data mesh. That's usually a couple of hours of work, for example. Now, so once the data has been sort of connected and it's flowing and you've put an API on top of it, and we can do this at vast scales. I mean, today, our global data network already handles billions of events per second globally. But it's really designed for trillions of events per second, And so this is an infrastructure designed to move data at vast scales at a very economical cost compared to the cloud. I mean, we can move data at 90% less cost and transform data at 90% less cost because of sort of some of the proprietary pieces over here. So this is the first piece of the journey. And then the second piece of the journey is now bringing business logic and orchestration to move your processing closer to where your data is originating or data is being consumed. This is the anti-cloud pattern. In the cloud, we ship data into compute.
Everything to the...
we ship data into the compute, which is very far away, sometimes intercontinental distances. Here we flip it and we ship the compute to where the data is. And so with MacroMeta, you can actually point us to your microservices, right? And we will surgically move those microservices that benefit, or need to comply with data regulations, for example, and keep them, distributed and move them into a region where that process is required. All of this is done dynamically. And that's why we call it a network, because it's routing a lot of these things and putting them in the right places for these things to execute. And, substantially, once you've done the global, you've kind of got the data mesh to integrate data, you've got your compute now that's serving data on top of that, or ingesting and processing data and analyzing data. Now you need to start worrying about the next order of problems, which is...
Yeah, I was going to say, protection of data, right? You mentioned it earlier in the podcast where you got GDPR, you got California's Privacy Act. So you need some kind of access control over all this data as well, right?
Exactly. And these are really hard problems. And the answers we have today are terrible. Your answer really is go and spin up a separate, spin up a separate silo, an instance of your app for that particular geo to comply with those particular, and then, every time you spin one of those up, you need a separate team. You've got your own security surface that is exploded. It's just an ugly, ugly way of doing things. And so, in MacroMeta's view, this is the data network that's already integrating and getting your data to flow across all these boundaries. Now you've got compute functions also, being able to serve and, ingest data on top of that without boundaries. Well, now we can basically create logical boundaries. And we can geopin and geofence data to specific regions. We can set affinities and policies about how data lives in a region, how it replicates. Should it be anonymized when it's replicated out of the region, for example?
See, I love your guys' approach because it put data as the primary.
Exactly.
Instead of the secondary, second-class citizen, which it has been for the last 40 years. I love that. This is a great approach. So... how do people find out more about this? About MacroMeta? Just go to your website, or how do they get in contact with you?
Yeah, the best way to learn more about MacroMeta is go to our website, www.macrometa.com. And, we've got a lot of educational material over here. It's a brave new world, and it's an exciting time, for folks who want to sort of explore this new frontier with us. What I can tell you is that there are some use cases that are, extraordinarily, they're impossible to do in the cloud. I call them impossible apps because the cloud's too far or it's too slow and it just is not a good purpose fit for these types of problems. And so for those classes of real-time data problems, we've built an infrastructure to solve them because we've been thinking hard about this for now 7-8 years about what the next 10 years of stateful data computing is in a distributed world. And that's what the platform is really designed to do. So I, as much as this is sort of my marketing spiel over here, I like to say that, the next 10 years are really about these global data problems. And, customers have all these emerging data problems. And, we're a platform that can help very quickly and easily turn them into opportunities rather than, being challenges.
Hey, Chetan, thank you again for coming on the show. This has been insightful. We most definitely want you to come back.
I'd love to,
because we can reminisce.
Yeah, let's talk about the early 2000s because I think that was sort of that was the Cambrian era of computer science to me because all the
absolutely
because and also maybe one last piece of reminiscing before I say bye. I almost feel like everything we do in the cloud is just basically putting a more fungible interface on top of mainframes. Literally every data structure invented in the mainframe world has become a service in the cloud.
Yep, it has. You're right. Yeah, we got to change that paradigm. We do.
Yeah, exactly.
So, all right. Hey, thanks again, Chetan.
My pleasure. Take care. Thanks so much for having me, Darren.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.